In the first video of the series, you learned about the basics of R, and in the second video, you saw how you can load a large Excel file in R and make it smaller. I showed you a number of ways to do that. I want to go into the details of those different methods, but before I do that, I need to cover an important concept, and that is vector. We already introduced them in the first video, but here we'll elaborate on different ways to create vectors, and I'll also show you how data frames and vectors are intricately connected. I'll show you 4 ways of creating vectors. This is only a subset of what you can do in R. Vectors are central to R, so they are at the heart of everything you do. There are many different ways of creating vectors. The first way is this 1:10. So here it means you get all the integers from 1 to 10. You can also do 45 to 75, and it will give you all integers from 45 to 75. You can also do SEQ 1, 10, 0.1. So this time it will start from 1, go all the way to 10, but in increments of 0.1. If you use the colon option, then you can get increments of only integers. Here you can get increments of 0.1. So 1.0, 1.1, 1.2, 1.3, 1.4, and like that all the way to 10. If you look at these numbers in the square bracket, they are just telling you which position in the vector this number is. So this is the first number of the vector, this is the 16th number, this is the 31st number, and this is the 91st number. So you can see that the size of this vector is 91. The next way of creating vector is if you want to have the same number many times. And the way to do that is to use the function repeat or repeat. So let's say you want to have 2 10 times. So 2, 2, 2, 2 all the way to 10 times. The fourth way is to create any arbitrary vector, and that's to use the function C, which is a collection. So you type the numbers, say 21, 75, 12.323, 91, and it gives you a vector with these 4 numbers. And you can type 40 numbers if you have time, or more, or any number. But this method doesn't work if you have a very large vector. You cannot really type all those numbers. I'll show you later that you can load numbers from a file and then pick up those columns as vectors. Let's talk about that later in the video. Now, one advantage of vector is that you can do many operations on the entire vector. For example, if you have 1 to 100, let's say x equals 1 to 100, you can do square root of x, and R will compute the square root of all of these numbers. So you are doing a calculation on the entire vector. And similarly, you can do sine of x. It will give you the sine of all of these numbers. Any function that you have in R that you operated on a single number, you can use it on a vector. But there are other functions which are not meaningful if you have a single number. They only work on vectors. So here is an example. Let's say you have x equals 1 to 100. You do sum of x. It doesn't make sense for single number, but on sum of x with a vector, it adds all of these numbers and gives you the sum of all integers from 1 to 100. Another function that you can use with a vector is plot. So let's say you do plot of x. R will open another window and show you the plot. So you are showing all the numbers from 1 to 100. Here the x-axis is the index on the vector, and y-axis is the number. Another option is to have two vectors. Let's say you do x equals 1 to 100 and y equals square root of x. You can do plot of x comma y, or we'll plot scatter plot with x and y on two axes. So here on the x-axis you have x, and on the y-axis you have square root of x. So this shows you how you can use R as a graphing calculator, because this plot function gives you the plot of any vector that you have. While on the topic of vectors, I wanted to show you a few other things. So let's say you have a vector x equals 1 to 10 and y equals uh, repeat of 7 times. So x is 1, 2, 3, 4 all the way to 10 and y is 7 many times. If you remember the C way to create vector, so we use C and then added a set of numbers to create a vector. You can use C on vectors. So if you do C, X, and Y, then that will concatenate these two vectors and give you a larger vector with all these individual vectors in it. And also you can do C, X, Y, and then do 12, 34, and then do X again. So here you have X here, you have Y here, you have 12, 34, and X again. You can use C on vectors and scalars, both. The other thing I wanted to show you is when you use the colon operator, you can also go in the opposite direction. So if you do 70 colon 9, it starts from 70, goes all the way to 9. All right. Now, vectors can be made of characters or string as well. If you do C, James, Harry, and it will create a vector with these three names. And sometimes you use these kinds of vectors for naming files, or if you want to create a spreadsheet with data, you can use vectors for names and vectors for numbers. Now, I wanted to also show you number of other functions that you can use on vectors. You saw the function sum. Let me clear my screen. Let's say x equals 1 to 10, 1 to 100. You can also use these following functions for vectors. One is head. If you do head of x, it will pick 6 numbers from the beginning of the vector and give you. You can do head of x 10. It will pick 10 numbers from the beginning of the vector. If you instead do tail of x comma 10, it will pick 10 numbers from the end of the original vector. So x is all the integers from 1 to 100. Tail of x gives you these 10 numbers, and head of x 10 gives you these 10 numbers. So these are two functions that you will use from time to time. We already talked about sum of x. It adds all members of x and gives you the sum. A few statistical functions are mean of x. It computes the mean of the vector x. Also, you can do median of x. And then you can do standard deviation, that's SD of x. And then also you can compute the variance of x, var x. So these are the different functions that are quite useful. Let me do Control L. So the last two functions are standard deviation x and var x. There are a number of other functions. I'll not go into them, but these functions that I discussed will come time to time, because when you create a vector, you may want to do statistical calculations. So sum, mean, median, standard deviation, variance, they all become quite meaningful. the vectors and data frames are tied to each other, and I'll show you how they are interconnected. You can create a data frame from vectors, and also if you have a data frame, you can go back to the individual columns as vectors. So if you remember, we read this file called data.csv, which has names, weights, and ages of number of people. Here I'm going to create the same data frame, but instead of reading them from the file, I'll create them from a vector. So here is what you do. You do name, and then I'll use the same names as before: Alex, Ada, Tin, Kim, and John. These are the names, and I create them using the C vector operator, which collects the names and creates a vector. Now for weight, I do weight equals C, and then 80.2, 70.1, 92.3, 77.7, and 68.2. So this is the weight, and then age equals C of 20, 21, 20, 17, and 19. Although I'm typing them as vectors, think of them as vertical, and you can imagine how they can become the columns of a spreadsheet or data frame. So think of name written all vertically, weight written vertically, and age written vertically. And here is how I'll combine them into a data frame. The command is data.frame, and then you can use different vectors, name, weight, age, and it will create this spreadsheet where you can see name is first column, weight is the second column, and age is the third column. It's identical to the file data.csv that I read, but instead of reading from an external file, I created the vector manually. So you can do df equals data.frame, name, weight, and age. So the question is, if I have a data frame like this, how can I get these individual vectors? For example, let's say you do not create the data frame from the vectors. You read the data frame from a file. So you do df equals read underscore csv, and then data.csv. This is how we read the df previously. Let's clear the screen. So here df is a table. Table is just the data frame with certain advantages for displaying the data. If the file is too big, a table will show only the first 10 lines, whereas if you have a data frame, it will show everything on the screen. But other than that, a table is just a data frame. So here I have this data frame. I did not create these vectors name, weight, and age. Instead, I read them from a file. How do I get the first column as a vector? So to do that, you do df $name, and that's a vector and gives you the first column. So what you do here is take the data frame, put $sign, and then give the name of the column that you want. If you want the weight column, you do df weight. And you can store it as, say, y. If you type y, it will give you this column. And similarly, you can get this column as df $age. And often we go between these two formats because sometimes you have the vector, you want to go to the data frame, and sometimes you have the data frame, you want to go back to the vector. One reason we may want to go between the data frame and vector is if we want to plot the, let's say, weight versus age of these people. So what you do is call it w equals df $weight, and a equals df $age, and then let's do plot of a and w. So I'll have the age on the x-axis and weight on the y-axis, and here is the plot. You can see it shows all these edges here and the weights here.